Okay, fingers crossed it doesn't fall again. Okay, so let's start with the warm-up, guys. Yeah, start with the warm-up. Oh, also, yeah, we get to color today, guys, so if you want your notes to be colorful, if you want your homework to be colorful, you can you guys brought yours. I have colored pencils and markers back there in the clear drawer. Be really careful not to shake the file cabinet, knock my phone over, please. And thank you. Free chargers. Alright, well, we are going to start with our warm-up. Alright, we spent almost 2.5 days on the last lesson. Alright, this lesson is much shorter and it's stuff you've seen before. This will not be new to you.
Oh, that's just dandy.
No. Yeah. Yeah.
How long is this lesson for?
Let's see. If you do want graphs, it is all graphing today. So if you want graphs, I have some cut out. Yeah, back there. And then I have graph paper too. Or you can just use your paper. That's fine for your notes, but make sure for your homework. Your homework worksheet. Oh wait, that's my fault. Yeah, what kind of function is this one going to be, guys? This is a step function, so make sure your graph looks like a step function. Alright, got the double bracket, make sure it's a step function. Think about, can you use the cheat? Can you use the shortcut? You can use the shortcut, guys.
Oh wait, yes you can.
You can use the shortcut. It does look right. Pretty sure. What were you grabbing? Except don't actually draw.
Oh, I wouldn't know.
Okay.
I'm just showing.
Yeah. Looks like steps. You got it? I would offer if someone wants to come up to the board, but we all know how finicky my board is. Oh, I'm very sad.
I love boards. Yeah. I love going up there. But now I
You can fill it if you want to. You can.
I'm good.
What?
I summoned
You just
Sears
said I
Spears
totally
to
go
the
up and
table.
go to the board.
I'll try it.
Okay.
If it like doesn't work, then I'm not good.
All right.
I said Sears Spears, not really one.
You know, I've had this board now.
Ha! No. It was occupied like a hole.
I've had this board now for what? This is my 5th year, so this is my 5th year with it. I know it's you know, it's kinks, so we kind of.
That was kind of funny.
You want to sit down.
Yeah, it's literally, that was a funny scoff you did.
So my question to you guys, I already asked, can we use the shortcut?
No.
Yeah.
Yes, right? Remember, you can't always use the shortcut, however, I can for this one. Why? Why can I use the shortcut? Because the 2 is outside the greatest integer function, right? If that 2 was inside those double brackets, I could not use the shortcut, but it's not, so I can. So what am I actually going to graph then for my shortcut? What am I actually graphing, guys? Why am I starting at 1?
Because
Y
there's one
equals
in front of
2x
the
plus
integer.
1, right? So I'm actually going to graph y equals 2x plus 1, right? I'm going to make it a linear function. Now, I always harp on you that you can start at the y-intercept and move your slope. But do I have to start at the y-intercept? No, when it's in slope-intercept form, and you can actually start at the y-intercept because it's on the graph, then for sure, right? What are the two things you need to graph a line? A point and a slope, or do you have to have a slope? No, so either a point and a slope, or what's your other option? How many?
Oh,
Two. Either 2 points, or you need a point and a slope, right? Okay, so this, though, is nice, right? I have a nice y-intercept that's on my graph, so I can start there, right? That's just one of those special points. It's still just a point on the graph. So where am I going to start then?
1.
At 1. On the y-axis, right? Right? Don't start it on the x-axis, it's the y-axis. Okay, from there, how do I move? Up 2 over 1, right? My slope is 2, so up 2 over 1. What a dot. Or going this way, right? Now, if it was a linear function, what would I do? I draw the line, but it's not. What is it? Step function. So instead of drawing the line, I'm just going to, oh, that is off. I didn't think that was right. All right, instead I'm going to make my little steps, right? Go over, open circle.
I can't imagine drawing a step function on this board.
Yeah.
That's gotta be awful.
Okay. Hopefully yours looks a little more neat than mine since you can actually control where your pencil is.
Yeah.
Okay, any questions with this? Do we feel more comfortable with step functions now that we've kind of spent a couple days on them? All right, this was brand new to us. Yes, Logan?
So the shortcut is if the number's outside of the bracket things.
As
That's when you do the cheat.
As long as there's not a number right here, you can do the shortcut. Yeah. As long as that's 1, you can do the shortcut. Doesn't matter what's outside of it. Okay? So any questions on those?
If it's like x plus 1 and it's on the bracket, would that...
Still fine. Okay. It just can't be the number in front of it, because that's either going to make the steps shorter or it's going to make the steps longer.
Oh, so...
That's what that changes.
If the x is being multiplied with anything inside the brackets, it's okay. If it's being added or subtracted,
It's
it's
fine.
fine?
Yep.
Okay.
It just can't be multiplied, because then that's going to make our step shorter or larger. In which case, then we would have to do the intervals. Okay. Some of you already turned your homework in. If you haven't yet, I want 3 piles. All right. Piecewise step function and book work. I need 3 piles. Half of you, I think, turned it in. So I have it in my pile. I was going to start grading it, and I didn't get to it. Stapler, right here. Yep. Yeah. Make sure your name's on it, guys. I still have like 4 papers in my no name bin. Some of them are Algebra 2 stuff, so I don't know if they were.
Are you in worksheet? I'll take it.
I don't think so.
Sorry, Cameron.
I will have all of your grades updated with everything that's been turned in absent or late actually it should already be in. I think there's only, I only have 1 that I haven't graded next week. So if you think you turned something in and it's a 0 in the grade book, you might want to check the no name bin.
No, that's not mine.
Cups this weekend, bring them again.
What is this stuff?
Also, if anyone wants, I have something
Candy?
somewhere.
Hey, you forgot the joke.
Oh, I
What?
did forget the jokes. Oh my gosh. I'm so
Yeah,
focused
that's
on
me.
everything else. I totally spaced on the jokes.
Can I look some up?
You want to look
No.
some up? They better be appropriate.
They're gonna be so bad.
Internet jokes are big.
Unless you.
Here we go. I knew they were in this file. If anyone wants any extra practice on piecewise functions, I have a worksheet if anyone wants extra practice on it. Also though, we were gonna have the test next week on Halloween, right? That was the plan. However, I have decided for us to do a project instead.
Oh,
We're still gonna do the test, it's just gonna be the next week.
Oh, thank goodness.
Okay, so we're gonna do a project and it's gonna take both days. Okay, both Tuesday and Thursday next week, we're gonna work on this project.
Oh, yeah.
Tuesday, you guys are gonna start by drawing your picture,
Oh, drawing.
and then we're gonna work with Desmos. Yes.
Alright, I have to jump.
Jokes, here we go. Everyone listening?
Why is 2 plus 2 equals 5 like your left foot?
Change the joke, I don't like
It's
it.
not
It's
right.
not right.
Yeah.
Did we do why was the tomato red? Did we do that joke? We haven't done why was the tomato red?
Because there was a very.
Because he saw the salad dressing.
Oh, I was wondering than your jokes.
What do you do if a teacher rolls her eyes at you? Pick them up and roll them back to her.
That's great.
Comedy.
It sounds like rolls her eyes.
Yeah, which I do all the time.
Oh, yeah.
What's a math teacher's favorite dessert?
Oh, pie?
Yeah.
But yes, nice. All right. So anyway, like I said, today we get to color. You guys get to be like your
Sixth grade.
your inner child gets to come out today.
No,
Okay?
don't let it come out. I don't like coloring.
Okay, this is our last lesson of chapter 2. This is our last lesson of chapter 2. Like I said, next week when I see you on Tuesday, we're going to start our project and we're going to finish it on Thursday, unless you don't finish it, in which case then it becomes homework. The following week, Monday then, we're going to review and do like story problems, and then Wednesday's going to be our test. That means though, guys, we're not having another test on quarter 1 grade. So, if you're not happy with your quarter 1 grade, the only thing you can still do at this point in time is retake that quiz. And turn in all your homework and get 100% hopefully on your homework. And if not, redo your homeworks. Right? That's about it. Because November 5th is the last day of quarter 1, and I'm pretty sure your test now falls on the 6th, if I remember correctly. Someone want to help me with that? I'll look at my calendar. Okay. Yeah, because I'll see you the 6th. So yeah, that test will be the first thing that goes in for quarter 2 though. So, if you want to start out the quarter well, we want to do well on the test. So hopefully this project we do really helps you with piecewise functions. That's what most of it's going to be. So, anyway, like I said, we're going to do the last lesson of chapter 2 today, so we're graphing inequalities, right? This is where we get to have fun and we get to color, we get to be colorful.
I don't like colors.
And use your pencil.
You can, that's fine, you can just use your pencil.
Okay.
It doesn't have to be colorful, I'm just saying you can use color if you want. Okay, so, I have an example up here, right? This was what it's going to look like for graphing an inequality. We did this in Algebra 1, hopefully we kind of remember it. Alright, so if I have the inequality y is less than or equal to 3x plus 4, right, you're going to draw the line y equals 3x plus 4, and then, do you remember, is the line always solid?
No.
No, what else can it be?
Dotted.
Yeah, dotted or dashed, yeah. Do you remember when it's which one causes it to be that?
No.
Isn't it 2 versus just or plus?
Yeah, so like if it's or equal to, right, and it's your solid line. If it's strictly greater than or strictly less than, it's going to be dashed. Right, just like when we were graphing on the number line for inequalities, right, open circle, closed circle, kind of the same thing, solid line, dashed line. Okay, so anyway, the line we draw though is called the boundary of the region, right, and we're either going to shade above it or we're going to shade below it. Okay, so does everyone have this? Are we still going? If you're putting this in your notes, like I said, it's your notes. Okay, notice my line has what on the ends of them? Because of the lines, arrows. I'm going to tell you right now, I will take off points if you draw line segments. These are lines. Make sure you put arrows on them. So like I said, we get to shade above or below. So if you want to use color, feel free. If you want to just shade with your pencil, that's fine too. I don't care as long as you shade the right side or the right half, right? Okay. If you haven't written that down, make sure you write that down. Solid line if it's greater than or equal to, less than or equal to, and then dashed line if it's less than or equal to, right? If it doesn't have the or equal to, it's dashed. Yes?
Wait, what does the dash line look like?
So,
Oh.
just like that, yeah. Alright, so, do you remember, did we talk about it this year? Did we talk about what it means to be a solution of an equation? Did we talk about that this year? I know we did a couple years ago, but did we talk about it this year? Do you guys remember what does it mean to be a solution to an equation? Like, if I gave you this, what's the solution to that? 7, right? 7 is my solution.
It's whatever makes the statement true.
Thank you. Oh my gosh, yes! It's whatever value or values makes the equation or the inequality true, right? It's what number can you plug in that makes it true. Now, is it always 1? Is there only one answer? For this one, yes. But if I have an inequality like this, how many solutions would make that inequality true? Anything where?
Less than or equal to 3x plus 4.
Right? Pretty much anywhere in here, actually anywhere in here, doesn't matter, any of these points, including points on the line, right? Because it's a solid line, so it means or equal to, so it can be the line, right? Any point in there is a solution to this inequality. So how many solutions does this have? Infinite, right? There are infinite solutions, okay? So when we go to start shading these, I'm going to teach you a couple different ways to do it, and you can choose which makes more sense for you, right? But the point is that this has infinite solutions. Every single point you can think of, whole numbers, fractions, decimals, everything inside the shaded region is a solution, and everything on that line is a solution. But when you have a dashed line, okay, your only solutions then are in the shaded region, right? The points on the line are not solutions because it's not or equal. Does that make sense? Yeah? Okay. All right, so let's go to some examples here then. You might want to write down what we just talked about a solution is. Hint, hint, nudge, nudge, wink, wink. Equation or inequality depending on what you're doing. Okay, so, right, I have a graph. Now, there's multiple different ways to graph this, right? Yes. We could graph it by intercepts, we could change it into y equals mx plus b, right? We could just pick 2 random points. However, when we deal with inequalities and shading, you're probably going to want to solve it for y. Because right now it's saying that it's greater than -3, right? So if we do method 1, where you figure out which way to shade based on the sign, you're going to want to solve it for y. Otherwise, if your sign flips, what causes a sign to flip in an inequality?
If you multiply or divide by negative.
If you multiply or divide by a negative, right? So if I were you, I would just solve it for y. You don't have to, you can graph it by intercepts if you want, but picking 2 points, but I would solve it for y. So if we were to solve this one for y, what would we do? Add x, right? I want to get y by itself, add x. Is that greater than -3x? Does that become -3x?
No.
No, those are not like terms, so I write it as
X minus 3.
oh God. There it goes again. Okay, all right, I'm going to write it as x minus 3. right? Or you can write it as negative 3 plus x if you want. Just remember, the number in front of x is your what? Slope, right? The constant added or subtracted at the end is your y-intercept, right? It is the special point we can start with if we're going to graph this. So if I was to graph this just based on that, where would I start? At negative 3 on the y-axis. I know I keep harping on that, but I always see people starting it on the x-axis. This is the y-intercept. Make sure you start it on the y-axis. Okay, from there, how do I move? Up 1 over 1, right? Yeah, it's okay. Then you have to determine, is it a solid or a dashed line? It's a dashed line, right? Because it's strictly greater than. Also, you guys should be using what to graph these? Rulers and erase straight edge, please. Especially when we get into solving systems of equations, because if you draw your lines and do it all willy-nilly and hope that you did it right, you might get a wrong answer because it doesn't actually cross where it's supposed to. Okay, now the question is where do I shade?
On
Above.
Above it, right? It's greater than, so I'm going to shade above the line.
Bless you.
Bless you. Okay, now, if you want to check that, or you're just not sure if you shaded the right side, right? Pick a number, right? Pick a point. So, if you can, pick the easiest point there is. What's the easiest point that you can use to plug in? 0, 0. So, as long as your line does not fall on 0, 0, that's the point I'd pick, okay? So, here's 0, 0, right? Plug that into your inequality here. Okay. Is 0 greater than negative 3?
Yes.
Yes. So if that's true, then that's the side that should be shaded. All right. Whatever side 0, 0 falls on the line, that's the side that should be shaded. Okay. Do you have to do this? No, you don't have to do this. This is if you want to check it or you're just not sure, because sometimes these lines are going to be pretty steep and it's like, okay, well, which one's actually above it, which one's actually below it? Okay, if you ever want to check, go ahead and pick a point. If you can pick 0, 0, it's the easiest point, right? Okay, any questions with this one? Okay, ready for the next one? Once again, you don't have to solve it for y. There's no negative, so really we don't have to solve it for y. But, I don't know. It seems easier just to solve for y because I'm x plus b. So what would I do if I wanted to get y by itself?
Subtract x.
I could subtract x. Where would I start?
2.
At 2. What's my slope?
Negative 1.
Negative 1. So down 1, right 1, right? Or up 1, back 1. Solid or dashed?
Dashed.
Dashed. Oh gosh. Okay, you guys know where that's supposed to be. bother calibrating it. Last time I calibrated it, just went even worse. Okay, so which one am I going to shade? Above, right? So which one's above this time? The right side. Right, last time though, above was actually the left side. What's different about it? The slope, right? Once again, you can always check it, pick a number, right? Pick 0, 0 again, it's not on the line, so go ahead and pick it. If I plug in 0, is 0 greater than 2? Is 0 greater than, no. So that means that wherever the 0, 0 is, that should be the side that's not shaded then, because that's not true. Is that how we have it shaded?
Yes.
Yes, right, 0, 0 is not shaded, which it shouldn't be. It doesn't make the inequality true. It's not a solution. It's not a long lesson today. So I said the goal.
Wait, how many more?
Two more.
2 more slides?
Yep, 2 more slides, 2 more graphs. The goal is, you know, it's a long weekend this weekend. I don't want you to have homework, so hopefully you can get it done in class. That's the goal.
Thank you for your kindness.
You're welcome.
Get that, Cameron?
Is that 2 slides excluding this one?
Yeah.
Okay.
Um,
one graph.
oh. Just out of curiosity, right? If I was, remember if I was to graph this by intercepts, do you remember what we do? No. Remember if you want to find the y-intercept, we plug in
X. No.
0 for x. We just did
Yeah.
this. Yeah? Right, remember we covered it up? What would your y-intercept be? Just 2. So pretend it's not a greater than.
Oh,
What's your x-intercept?
2.
2. I know my graph doesn't work out, but did that actually happen? Yes. Can we graph it by intercepts? Yes.
Oh, cool.
Right. The only time you might want to be careful with that is if we have negative numbers we're going to be dividing by. That's where you want to be careful. So, this one, what am I going to do? Subtract 2x. I'm going to solve it for y.
Oh, that's beautiful.
Oh dear. You might have to recolor.
I might have to try that again.
Modern art.
I know. You guys knew I was an artist, right?
Oh yeah. Oh, see now. Oh, I forget saying anything.
You guys, do you know what? You guys know what it is. You guys know what it is. You know what it's supposed to be. You're doing it on your own paper. Okay, then what?
Divide by 3.
Divide by 3. 2. Oh God, everything.
Something that looks worse than my handwriting. What?
Does 3 go into 2? No, so I have to leave it as a fraction. And negative 3 divided by 3 gives me negative 1. Alright, so if I'm going to put it in slope intercept form now, where am I going to start? Negative 1. How am I going to move?
Down
Up
one.
2,
Down
down over 3, and going to the left.
Yeah, so I can either go up 2 and then back 3, or I can go down 2 and right 3. Right, rise over run. Okay, solid or dashed line? Solid, because it's or equal to. That's pretty close. Oh, good enough. It's hard to press forward. Okay, so just out of curiosity, right? If I cover up my x, I plugged in 0 for x, what's my y-intercept?
Or
Negative one, negative one. Okay, look at that. If I cover up my y, because I'm plugging in 0 for y, what does my x become? Close, sweet. Negative 2, 3. Negative. It's all for x, guys. What would you do?
negative 3 over 2.
Negative 3 over 2, right? You gotta divide by 2. You know, it's kind of hard not writing it down. So what's negative 3 over 2?
1.5.
Negative 1.5. Is that where it hits?
Yep.
Yep. Anyway, which way am I gonna shade?
Up to the bottom.
Bottom. I want below. I want below. It's less than. Once again, though, right? Pick a point, plug it in, check to make sure it works. If I plug in 0, 0. Is 0 less than or equal to negative 1? No. Which means the side that has 0, 0 should not be shaded. Is that the case?
Yes.
Yes. Any questions so far? Pretty easy, right? Graph your line, figure out if it's solid or dash, figure out which way to shade. Okay.
I think we're ready for the homework.
Oh no, I got one more for you. This is gonna be really tricky. It's gonna be so tricky.
White was.
Oh my goodness!
I don't know how you expect us to do this.
I know, gosh, I'm such